Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Welcome to GTC! I just want to remind you, this is a tech conference. All these people lining up so early in the morning, all of you in here, it's great to see you. GTC. GTC, we're going to talk about technology. We're going to talk about platforms. NVIDIA has 3 platforms. You think that we mostly talk about one of them. It's related to CUDA-X. Our systems is another platform, and now we have a new platform called AI Factories. We're going to talk about all of them. And most importantly, we're going to talk about ecosystems. But before I start, let me thank our pre-game show hosts. I thought they did a great job. Sarah Go of Conviction. Alfred Lim, Sequoia Capital, NVIDIA's first venture capitalist. Gavin Baker, NVIDIA's first major institutional investor. These 3 people are deep in technology, deep in what's going on, and of course, they have just a really broad reach of technology ecosystem. And then, of course, all of the VIPs that I hand-selected to join us today, all-star team. I want to thank all of you for that. I also want to thank all the companies that are here. NVIDIA, as you know, is a platform company. We have technology, we have our platforms, we have rich ecosystem. And today, there are probably 100% of the $100 trillion of industry here. 450 companies sponsored this event. I want to thank you. 1,000 technical sessions, 2,000 speakers. This conference is going to cover every single layer of the 5-layer cake of artificial intelligence, from land, power, and shell, the infrastructure, to chips, to the platforms, the models, and of course, the most important, and ultimately, what's going to get this industry taken off is all of the applications. What it all began here. This is the 20th anniversary of CUDA. We've been working on CUDA for 20 years. For 20 years, we've been dedicated to this architecture, this revolutionary invention, SIMT, single instruction, multi-threaded, writing scalar code could spawn off into multi-threaded application, much, much easier to program than SIMD. We recently added tiles so that we could help people program tensor cores and the structures of mathematics that are so foundational to artificial intelligence today. Thousands of tools and compilers and frameworks and libraries. In open source, there's a couple of 100,000 public projects. CUDA literally is integrated into every single ecosystem. This chart basically describes 100% of NVIDIA's strategies. You've been watching me talk about this slide from the very beginning. And ultimately, the single hardest thing to achieve is the thing on the bottom, installed base. It has taken us 20 years to now have built up hundreds of millions of GPUs and computing systems around the world that run CUDA. We are in every cloud. We're in every computer company. We serve just about every single industry. The installed base of CUDA is the reason why the flywheel is accelerating. The installed base is what attracts developers, who then creates new algorithms that achieves a breakthrough. For example, deep learning. There are so many others. Those breakthroughs leads to entirely new markets, which builds new ecosystems around them with other companies that join, which creates a larger installed base. This flywheel is now accelerating. The number of downloads of NVIDIA libraries is incredibly accelerating. It's at a very large scale and growing faster than ever. This flywheel is what makes this computing platform able to sustain so much applications, so many new breakthroughs, but most importantly, it also enables these infrastructures to have extraordinarily useful life. And the reason for that is very obvious. There's so many applications that you can run on NVIDIA CUDA. We support every single phase of the AI lifecycle. We address every single data processing platform. We accelerate scientific principled solvers of all different kinds. And so the application reach is so great that once you install NVIDIA GPUs, the useful life of it is incredibly high. It is also one of the reasons why Ampere, that we shipped them some 6 years ago, the pricing of Ampere in the cloud is going up. And so all of that is made possible fundamentally because the install base is high, the flywheel is high, the developer reach is great. And when all of that happens, and we continuously update our software, the computing cost declines. The combination of accelerated computing, speeding up applications tremendously. Meanwhile, as we continue to nurture and continue to update software over its life, not only do you get the first-time pop, you get the continuous cost reduction of accelerated computing over time. And we're willing to nurture, willing to support every single one of these GPUs in the world because they're all architecturally compatible. We're willing to do so because the install base is so large, if we release a new optimization, it benefits millions. This applies to everybody in the world. This combination of dynamics is what makes the NVIDIA architecture expand its reach, accelerating its growth, at the same time driving down computing cost, which ultimately encourages new growth. So CUDA is at the center of it. But our journey to CUDA actually started 25 years ago. GeForce I know how many of you grew up with GeForce. GeForce is NVIDIA's greatest marketing campaign. We attract future customers starting long before you could afford to pay for it yourself. Your parents paid. Your parents paid. Your parents paid for you to be NVIDIA customers. And every single year, they paid up year after year after year until someday you became an amazing computer scientist and became a proper customer, a proper developer. But this is the house that GeForce made. 25 years ago, we started our journey, which led to CUDA. 25 years ago, we invented the programmable shader, a perfectly unobvious invention to make an accelerator programmable, the world's first programmable accelerator, the pixel shader. 25 years ago, that led us to explore further and further. 20 years later, 5 years later, the invention of CUDA. One of the biggest investments that we made, and we couldn't afford it at the time, and it consumed the vast majority of our company's profits, was to take CUDA on the backs of GeForce to every single computer. We dedicated ourselves to create this platform because we felt so strongly about its potential. But ultimately, the company's dedication to it, despite the hardships in the beginning, believing in every single day, for 13 generations or 20 years, we now have CUDA installed everywhere. The pixel shader led to, of course, the revolution of GeForce. And then 10 years ago, we introduced, about 10 years ago, 8 years ago, we introduced RTX, a complete redesign of our architecture for the modern era of computer graphics. GeForce brought CUDA to the world. GeForce, therefore, enabled Alex Krizhevsky and Ilya Sutskever and Jeff Hinton, Andrew Ng, and so many others to discover that the GPU could be their friend in accelerating deep learning. It started the big bang of AI. 10 years ago, we decided that we would fuse programmable shading and introduce two new ideas ray tracing, hardware ray tracing, which is incredibly hard to do, and a new idea at the time. Imagine, about 10 years ago, we thought that AI would revolutionize computer graphics. Just as GeForce brought AI to the world, AI is now going to go back and revolutionize how computer graphics is done all together. Well, today I'm going to show you something of the future